Let's do a problem. In this problem, we have to show that in a circle, longer chord is nearer to the center. What this means is that in this circle with center O, we have two chords AB and CD, and it is given that CD is longer than AB. Then we have to prove perpendicular distance OF of chord CD will be lesser as compared to perpendicular distance OE of chord AB. In other words, chord CD is nearer to the center as compared to chord AB. Let's discuss the approach for doing this. And before we start the approach, as we have discussed that this is the perpendicular distance, so these angles will be right angles here. For proving this, we can join OB and OC. Let's explore if we can use properties of chords and Pythagoras theorem for proving OF is less than OE. With this approach, let's complete the solution. By Pythagoras theorem, in right triangle OEB, we can have OB square is equal to OE square plus EB square. Similarly, in right triangle OFC, we can have OC square is equal to OF square plus FC square. But we know that OB and OC are the radii of the circle, so they are equal. So LHSs of these two equations are equal, so RHSs will also be equal. So that means OE square plus EB square is equal to OF square plus FC square. Also, it is given that CD is greater than AB. So this will imply that half of CD is greater than half of AB. So this will imply we know perpendicular from the center bisects the chord. So OF bisects CD. So half of CD will be equal to CF. So CF is greater than half of AB. Similarly here, OE is the perpendicular from the center. It will bisect the chord. So half of AB here will be EB. So CF is greater than EB. This implies CF square will be greater than EB square. So if in this equation here, in place of EB, if we will write CF, which is a greater quantity, then this equality here will change like this, because we will be putting CF square here, which is a quantity greater than EB square. So this will imply from here we will have OE square plus CF square is greater than OF square plus FC square. CF square and FC square are one and the same thing. We can cancel this. So this implies OE square is greater than OF square, or this implies OE is greater than OF. And this is what we had to prove, that OE is greater than OF. That means the larger chord is nearer to the center of the circle. So in this video, we have learned how to apply property that perpendicular from the center bisects the chord. We have also learned how Pythagoras theorem can be applied to show that longer chord is nearer to the center of the circle.